My name is Thomas and my guest today is Achim. Good morning, Achim.
Good morning, Thomas. Hello, world.
So today is day 19 of Advent of Code and Achim solved this riddle. So, Achim,
Yes.
please explain us the riddle for today.
So, today we have to determine certain parts that are acceptable for use or not acceptable for use. And the elves come up with quite an elaborate rating scheme. So they have 4 qualities that they decided on. And we have some kind of rule set that we have to process parts through to determine whether they are acceptable or not. So our input looks like this. So we have our workflow rule set. We have a rule name, then we have a condition depending on one of the 4 attributes. And we have 2 follow branches. The left always leads directly to another rule, and the right might lead to another rule or introduce another condition. So these chains can get a little bit long. The second part of our puzzle input describes some parts with the attributes X, M, A, and S. Xmas. And that means that we need to implement 2 parsers so that we can determine which of these parts are acceptable. And once we've done that and have also processed our parts through and found out which one are acceptable, we can then add up their attributes. So for each accepted part, we sum up all the attributes, and then we sum the sums of all accepted parts.
Okay.
So much for part 1. So to the code. So this is my main procedure for part 1. I have my workflows, I have the parts. This steers the parsing, so the first few lines are the workflow. And once I encounter an empty line, I break this loop and go increment by 1 and continue with the next and parse the parts. And then I check any part if it is acceptable by the workflows that I have. And if yes, I take that part, take its attribute values, sum them up, and add them into the result.
Okay.
So going on to the parsers. The parser for the workflow starts here in the workflow constructor. I have a string tokenizer today, and I decided that that these brackets, the colon and the comma, are my delimiters, and I probably need them, so I decided that I want the delimiters also returned as tokens.
Also your string tokenizer uses these 5, 6 characters as a delimiter, and the true is that you need them. Okay.
That I also get them returned as tokens.
Okay.
So my first token is the name. The next token is an opening bracket. So I call next token to consume it, but don't really use it. And the other part that I store in the workflow is the operation that I need to do, which is a node. I decided to construct a tree. And the node also takes a string tokenizer and continues consuming parts from it. So The first item for each node is a field that it works on, XMAOS. The second one is the operator that would normally be a smaller than or greater than. But if we encounter the end of the list, we might also have a comma or a closing bracket there. Wait, that shouldn't have happened. So if we encounter one of these items, we keep it stored as the operation, but we terminate the constructor at this point. If it's none of these, so smaller than or greater than, we pass the reference value of the comparison. We skip the next token, and then we have a left and a right side where it can continue and instantiate new nodes for that.
Okay.
Well, knowing that the left node always only contains a single string, being the next operation or an acceptance or a reject. This might actually incur some other logic, but also may end in the next operation an accept or a reject command.
So you pass your input, you create your workflow and your node, and then?
And then I have this class rated part, which also contains a parser, the other parser for the parts. Here I just use a string splitteration on two different brackets, the equal sign and the comma. And I look on items in groups of 2 that are really interesting to me. So at the first position, I have the attribute itself. And at the second, I have its value. And these just continue on. So I have this 4 times and I just pass it through and store it in a hash map. My first approach was having distinct variables, but using a hash map was easier.
Okay.
Just looking what I'm using this constructor for. I think I don't need it any longer. Yes, that is not required. So to check whether the workflows accept my part or not, I start with the workflow named in. And take that root node, take the root node of that workflow, and process through the described workflow, and check whether I confer to certain conditions or not.
And you got 2 while loops, and you got a label again, an outer label in line
Exactly.
110.
I use that label here. Could have also used a break here to break the inner loop and just continue on the outer. Would have worked also.
Okay.
So if I encounter an item at the end of the workflow, I then check whether it's an A or an R. An A is an acceptance, and I return true. An R is a reject, and I return false. If I encounter something different, it is a workflow name. And I jump back to the outer loop, take that workflow and continue. If I encounter a real operation, so smaller than, greater than, I take the attribute that is determined by the tree node I'm currently on from the attribute set of my part and have its attribute value and check then whether it's smaller or larger than the reference value. If it confirms to the condition, then I take the left branch. If it doesn't, I take the right branch.
Okay.
Until I finally come to an accept or reject.
And this is all for part 1.
That is all for part 1.
Something else for part 1?
It took some time to code this all up, but it was fun.
It was fun. Okay. And can we come to part number 2?
Yeah, part number 2.
Yeah, what is the twist in part number 2 for this riddle for today?
The twist is that the elves come up with a new plan because I think sorting each part separately takes way too long. So they tell me, hey, give us a process through that thing and give us a mapping which parts are good and which parts are not. And for that, we are given a range of from 1 to 4,000, including the 1 and the 4,000 for each of the attributes. So we have 4,000 to the power of 4 combinations that are valid. If you multiply that out, you get this number.
This is very
Quite big. It's a 256 with 12 zeros following. Checking each single one brute force takes way too long. I actually did try that, but I expected that wouldn't work. And while that was still running, I was working on a proper solution. And at some point, I then decided to just skip the brute force approach because it didn't yield a result even on the test input.
So you have to start from scratch again? More or less?
A little bit. So for part 2, going to part 2's main method. So again, I pass the workflows, but I skip the entire part descriptions because I don't need them for part 2. And I have here a wrapper class called intermediate, which contains an operation to process and a range of parts to process it on. And the constructor for the part range class is quite simple. So I have 2 hash maps, one with the minimum values, one with the maximum values for each attribute. And I initialize them with the minimums at 1 and the maximums at 4,000 for all 4 attributes. And I also have a copy constructor where I just copy the contents of the map over. And processing this through, I take from my list of intermediates the first item, remove it from that list, take the range, and I take the name of the workflow. If it is an A, acceptance, I calculate the size of my range. If it is a rejection, I just skip it. This is just for debug purposes.
Okay.
If it is none of these, then I take the descripted workflow, take its root node, and process through. If the operation I'm presented with is a comma or a closing bracket, I put that range and the current operation on my to process stack, because in that case I'm probably in one of these areas or just have to forward to another workflow. But if I have a proper operation, then I probably need to split my range. So I take the descripted field, the operation, and the reference value, and go into this split method, where I decide whether I split the thing or not. So I take here the minimum and the maximum value that I have for that attribute.
Yeah.
Because if the split line would be outside my range, then I don't need to split at all. I just need to decide, is it the lower or the upper, on the left or the right side of that condition. So if the minimum value is below the lowest value that wait, I have to explain it differently. So I have a greater or lower decision based on a reference value. So I have here for the upper and lower part, minimum for the upper and the maximum for the lower part. I initialize both as a reference value. If I have the smaller than operation, I reduce the lower maximum by 1. Otherwise, I have the greater than operation, I increment the upper minimum, so that they are exactly one apart and such distinct. If I then find out that this division is outside my range, so in this case, my minimum is greater than the lower maximum, I don't need to split. I just return this range as a right side and null at the left side, and other way, when my maximum is smaller than the minimum value of the upper range, I do it the other way around. If it's not the case, so that I really need to split, then I create a new part range as a copy of the one that I'm currently working with, and modify the current range and the other range so that the current range is the lower half and the other one is the higher half, the upper half, and return them. And for the other operation, I have to make sure that I sort them in the right direction, in the right order. So you see that in this case, the the new part is on the left and the current element is put in the right.
Yes.
That was actually a problem that I hadn't in mind, and I lost a lot of time finding out that I screwed up at this point. Really, really, really stupid error.
Yeah.
Because for the greater than operation, I confused those two parts with each other, and that led to crazy results.
Yeah, this happens. What was the effect to your rank at the end?
Compared to part 1, I lost over 1,000 positions and came out at 4,022.
Okay.
That could have been better. So the remaining thing I have here now is the size method to calculate the size for a range when it got accepted, which I also use if it got rejected for debugging purposes. So I go through the set of the minimum attribute values, take get also the maximum value for that attribute, subtract them from each other, and just in case if my delta would be smaller than 0, then I would have to return 0 for the entire thing, because in that case the range would be completely invalid. If it's not, so even if this delta value nets 0, I have to add 1, because if I have a range from 1 to 4,000, I have 4,000 values, but 4,000 minus 1 nets 3,999. That's why I have to add 1 at this point.
Okay.
And multiply them up.
And that's it.
Yes.
Cool. What was the hardest thing for you this time?
That stupid bug.
Okay. Achim, then big thank you to you. A lot of effort. Wish you luck for tomorrow, and then we see us tomorrow again.
See you tomorrow. Goodbye.
Bye.